The National Electrical Code, specifically Section 250.24 A1, mandates that panel boards must be supplied by a feeder or feeders equipped with an equipment grounding conductor. This requirement holds true irrespective of whether the panel board is intended to serve only line-to-line loads and regardless of whether all available spaces within the panel board will be utilized. The grounded conductor, often referred to as the neutral conductor, serves a vital purpose in electrical systems. Its primary function is to provide a low impedance path for fault currents and to establish a stable reference point for the electrical system's voltage. Even in scenarios where all loads connected to the panel board are exclusively line-to-line, the presence of the grounded conductor remains essential for several key reasons. Firstly, it provides fault protection. In the event of a line-to-ground fault, the resulting fault current will utilize the grounded conductor as its path back to the source. This surge of current will then trigger the circuit breaker or fuse responsible for protecting the circuit. By quickly interrupting the flow of electricity, the grounded conductor plays a crucial role in safeguarding both the electrical system and personnel from potential hazards. Secondly, it provides voltage stability. The grounded conductor aids in maintaining a consistent and stable voltage level within the electrical system. It achieves this by acting as a reference point for the voltage, effectively minimizing fluctuations and ensuring a more reliable power supply. This stabilization is particularly important in systems that incorporate nonlinear loads, such as electronic equipment. These types of loads have the potential to introduce distortions into the voltage waveform, which can negatively impact the performance and longevity of other connected devices. Therefore, the inclusion of a grounded conductor in all panel boards is a fundamental requirement, regardless of whether it is actively being utilized to serve any connected loads. It's important to understand why this requirement exists. The grounded conductor isn't just an optional component. It's a critical safety element that contributes to the overall integrity and reliability of the electrical system. Think of it as a safety net, always there, ready to protect the system and its users in the event of a fault. Consider a scenario where a piece of equipment connected to the panel board experiences an internal failure, leading to a short circuit between a live conductor and the equipment's metal chassis. Without a properly grounded system, this fault current could energize the chassis, creating a dangerous shock hazard for anyone who comes into contact with it. However, with a grounded conductor in place, the fault current will instead flow through the low impedance path provided by the grounded conductor, quickly tripping the circuit breaker and energizing the circuit. This prevents the chassis from becoming energized and significantly reduces the risk of electric shock. Furthermore, the grounded conductor plays a role in mitigating electromagnetic interference, also known as EMI. EMI can disrupt the operation of sensitive electronic equipment and cause data corruption. By providing a low impedance path to ground, the grounded conductor helps to minimize the effects of EMI, ensuring the reliable operation of electronic devices connected to the panel board. The National Electrical Code Section 250.24 A1 clearly states the requirement for a grounded conductor. This requirement is not subject to interpretation. It's a fundamental rule that must be followed to ensure the safety and reliability of electrical installations. When installing or working on electrical systems, it's essential to adhere to all applicable code requirements, including the requirement for a grounded conductor at all panel boards. Neglecting this requirement can have serious consequences, potentially leading to electrical shock, fire, and equipment damage. While it may seem counterintuitive to install a grounded conductor when it's not immediately apparent how it will be used, it's important to remember the critical functions it provides in terms of fault protection and voltage stability. These functions are essential for maintaining a safe and reliable electrical system. In summary, the National Electrical Code mandates the presence of a grounded conductor at all panel boards, irrespective of the types of loads being served. This requirement is driven by the need to provide fault protection, voltage stability, and to minimize electromagnetic interference. Adhering to this code requirement is essential for ensuring the safety and reliability of electrical installations. If you're unsure about any aspect of electrical installations or code requirements, it's always best to consult with a qualified electrician. They can provide expert guidance and ensure that your electrical system meets all applicable safety standards. Let us delve a bit deeper into the specific aspects of Section 250.24(a)(1) of the National Electrical Code and its implications for panelboard installations. This section falls under Article 250, which is dedicated to grounding and bonding, a crucial aspect of electrical safety. The core of Section 250.24(a)(1) explicitly states that panelboards shall be supplied by a feeder or feeders with an equipment grounding conductor. This statement might seem straightforward, but its importance cannot be overstated. It mandates the inclusion of an equipment grounding conductor as an integral part of the feeder circuit that supplies power to the panelboard. The term equipment grounding conductor is significant. It refers to a conductor specifically designed to provide a low impedance path for fault currents from equipment back to the source. This conductor is typically made of copper or aluminum and is often identified by its green color or by green markings. Its purpose is to ensure that in the event of a fault, such as a short circuit to the metal enclosure of a piece of equipment, the fault current will flow through the equipment grounding conductor back to the source, tripping the circuit breaker or fuse and quickly de-energizing the circuit. This prevents the metal enclosure from becoming energized and posing a shock hazard. The requirement for an equipment grounding conductor applies to all panelboards, regardless of their application or the types of loads they serve. This means that even if a panelboard is only used to supply line-to-line loads such as 240 volts or 480 volts equipment, and does not have any line-to-neutral loads, the equipment grounding conductor is still required. This is because even in systems with only line-to-line loads, there is still a risk of ground faults, and the equipment grounding conductor is essential for providing a safe path for fault currents. Now, let's consider the scenario where you have a panelboard that is specifically designed to serve only line-to-line loads, and all of the available spaces in the panelboard will be utilized. In this case, you might be tempted to think that you can simply run two ungrounded conductors and an equipment grounding conductor to the panelboard, omitting the grounded conductor. However, this is not permitted by the National Electrical Code. As we have already established, Section 250.24(a)(1) requires that all panelboards be supplied by a feeder or feeders with an equipment grounding conductor. This means that even if the panelboard does not have any line to neutral loads, you still need to run a grounded conductor to the panelboard. The grounded conductor serves several important functions, even in systems with only line-to-line loads. Firstly, it provides a reference point for the voltage. In a three-phase system, for example, the grounded conductor provides a neutral point that is used to balance the voltage between the phases. This helps to ensure that the voltage on each phase is stable and does not fluctuate excessively. Secondly, the grounded conductor helps to reduce the risk of voltage transients. Voltage transients are sudden, short-duration spikes in voltage that can damage sensitive electronic equipment. The grounded conductor provides a path for these transients to dissipate ground, protecting the equipment from damage. Thirdly, the grounded conductor helps to reduce electromagnetic interference. Electromagnetic interference, or ME, is unwanted electrical noise that can interfere with the operation of electronic equipment. The grounded conductor provides a shield that helps to block EMI from entering the equipment. Now let's talk about the size of the grounded conductor. The size of the grounded conductor is determined by the size of the ungrounded conductors that supply the panelboard. The National Electrical Code provides tables that specify the minimum size of the grounded conductor based on the size of the ungrounded conductors. It is important to consult these tables to ensure that the grounded conductor is properly sized. Using a grounded conductor that is too small can create a safety hazard, as it may not be able to carry the fault current safely in the event of a ground fault. In addition to the size of the grounded conductor, it is also important to ensure that the grounded conductor is properly connected to the grounding electrode system. The grounding electrode system is a network of interconnected grounding electrodes that are designed to provide a low impedance path to ground. The grounding electrode system typically consists of one or more ground rods, ground plates, or underground metallic water pipes. The grounded conductor must be connected to the grounding electrode system at the service entrance. This connection ensures that the grounded conductor is effectively grounded and can provide a safe path for fault currents. In summary, Section 250.24 (1) of the National Electrical Code requires that all panel boards be supplied by a feeder or feeders with an equipment grounding conductor. This requirement applies to all panel boards, regardless of their application or the types of loads they serve. The grounded conductor serves several important functions, including providing a reference point for the voltage, reducing the risk of voltage transients, and reducing electromagnetic interference. The size of the grounded conductor is determined by the size of the ungrounded conductors that supply the panel board. It is important to consult the National Electrical Code to ensure that the grounded conductor is properly sized. In addition to the size of the grounded conductor, it is also important to ensure that the grounded conductor is properly connected to the grounding electrode system. This connection ensures that the grounded conductor is effectively grounded and can provide a safe path for fault currents. When installing or working on electrical systems, it is always important to consult with a qualified electrician. They can provide expert guidance and ensure that your electrical system meets all applicable safety standards. Let's delve further into the nuances of grounded conductor requirements at panel boards, expanding on the information and providing a more comprehensive understanding. We'll explore different scenarios, common misconceptions, and best practices for ensuring compliance with the National Electrical Code. Consider a situation where a panel board is located in a detached building or structure. In such cases, the National Electrical Code has specific requirements for grounding and bonding. Generally, a grounding electrode system must be established at the detached building or structure, and the grounded conductor of the feeder supplying the panel board must be connected to this grounding electrode system. This ensures that the panel board has a proper ground reference, even though it is located away from the main service entrance. Another scenario to consider is when a panel board is supplied by a separately derived system, such as a generator or a transformer. In these cases, the grounded conductor of the separately derived system must be bonded to the metal enclosure of the generator or transformer, and the grounding electrode conductor must be run from the generator or transformer to the grounding electrode system. This creates a proper ground reference for the separately derived system and ensures the fault currents can flow safely back to the source. Now let's address some common misconceptions about grounded conductors at panel boards. One common misconception is that the grounded conductor is only necessary for line to neutral loads. As we have already discussed, this is not the case. The grounded conductor is required for all panel boards, regardless of the types of loads they serve. Another common misconception is that the grounded conductor can be omitted if the panel board is located close to the service entrance. While it is true that the length of the grounded conductor can affect its impedance, it is still required, even if the panel board is located close to the service entrance. The National Electrical Code does not provide any exceptions for this requirement. It is also important to understand the difference between a grounded conductor and an equipment grounding conductor. The grounded conductor is intentionally grounded at the service entrance, while the equipment grounding conductor is not intentionally grounded. The equipment grounding conductor is connected to the metal enclosures of equipment and provides a path for fault currents to flow back to the source. The grounded conductor provides a reference point for the voltage and helps to stabilize the voltage in the electrical system. When installing or working on electrical systems, it is important to follow best practices for grounding and bonding. This includes ensuring that all grounding connections are clean and tight, using the correct size of grounding conductors, and properly connecting the grounding conductors to the grounding electrode system. It is also important to inspect the grounding system regularly to ensure that it is in good condition and that there are no loose connections or corrosion. Failure to follow best practices for grounding and bonding can create a safety hazard and increase the risk of electrical shock, fire, and equipment damage. In addition to the technical aspects of grounded conductor requirements, it is also important to consider the legal and regulatory implications. Electrical installations must comply with all applicable codes and regulations, including the National Electrical Code. Failure to comply with these requirements can result in fines, penalties, and even legal action. It is therefore essential to ensure that all electrical installations are performed by qualified electricians who are familiar with the applicable codes and regulations. When selecting an electrician, it is important to choose one who is licensed and insured. A licensed electrician has met the requirements of the state or local jurisdiction and is qualified to perform electrical work. An insured electrician has insurance that will protect you in the event of an accident or injury. It is also a good idea to check the electrician's references and read online reviews before hiring them. In conclusion, the grounded conductor is a critical component of electrical systems, and its presence at all panel boards is mandated by the National Electrical Code. The grounded conductor serves several important functions, including providing fault protection, voltage stability, and reducing electromagnetic interference. When installing or working on electrical systems, it is important to follow best practices for grounding and bonding and to comply with all applicable codes and regulations.